Good morning, this is your stats sensei, Mr. Spensei, and this is going to be a warm-up for the paired T. And some of you are going, hey, we haven't learned how to do the paired T. And I'm going to say, well, it's almost exactly the same as doing a one sample T, so you kind of know it. So try it out. So sick leaves. To compare the mean number of lesions caused by two virus strains on tobacco leaves, the strains were randomly assigned and placed on half of a tobacco leaf with 8 leaves receiving both strains. Here's the thing. When you're working with paired, we did this at the beginning of the year, something is typically tested twice. All right. And here we're testing the leaf twice. It's getting it's getting both strain one and strain two, all 8 of them. All 8 leaves will get each of the strains. The lesions appeared and were counted, and the differences were recorded. So leaf one had 21 of strain one and 18 of strain two. So they counted them up. So you need to take that data and put that into column L1, column L2, and column L3. Now I have this is out here to check you out. So if you go stat edit and you go stat calc, one var stat, and you check L1, oh, my standard deviation is 5.8002. So I know I got my data in there right. So do that for all of them. Now you're like, wow, we got 3 columns of data. And I'm like, well, I'm going to show you a shortcut. So that's 21 minus 18 gave me 3. 20 minus 17 gave me 3. 18 minus 14 gave me 4. 17 minus 11 gave me 6, etc., etc., etc. Now, I could have shortcut it by just putting in L1 and L2 and going to the top of L3, press the blue button, the number 1 minus the blue button, number 2. So I have L1 minus L2, and it populated it with the numbers that I wanted. So it gave me the numbers that I wanted. All right. Test the differences at alpha equal 0.05 to determine whether virus strain 1 produces more lesions than virus strain 2. Huh. Well, more tells me greater than. I know that. So here's my formula. Well, it's exactly the same formula, except we dropped some D's on it. The sample mean of the difference, the population mean of the difference, the standard deviation of the difference, and the square root of n. Well, they didn't tell me what the differences is. And there's a reason for that. When there is no difference, when it's this, we are expecting there be no difference. All right. And we already said, hey, more is greater than. So we're saying, um, whether lesion one is more than lesion two. And the way I look at it is one, because they asked for one first, and two second, they said, oh, one greater than two. Is group one greater than group two? That's what they're asking us to do. So no difference means, hey, it's exactly the same. Well, what did we actually get? Let's go ahead and go stat, calc, one var stat, and look at L3. All right, second 3. And we ended up with a sample mean of 2.75. And we had a sample standard deviation of 2.314. And we know our sample size is 8 because we have 8 pairs. So actually what we care about is not L1 and not L2. We actually care about the differences. So we're going to plug in and we're going to go T equals 2.75 minus 0, 2.3145 over the square root of 8. Now I got to tell you something. Do you really need that 0? And the reason I'm bringing this up is I saw one year on a multiple choice test, they just had it like that without the 0, and people freaked out. They didn't recognize it because it didn't have the 0. All right. So we're running a one sample T test because it's still one sample. This is a sample for, now this is where it's going to be different, for the mean of the, what are we taking the mean of? Oh, the mean of the differences. All right. So let's go ahead and run this thing. Stat test, t-test. Well, we're working with data. Well, we set our mean as 0. Be careful here. The list that we're looking for is the one in L3. So blue button 3. We have a greater than. Oh, you know what? I didn't draw that picture. I should have. We're expecting it to be at 0, but we got a 2.75 X bar. And we're looking for this way shaded up. This is greater than, and that's our mean. All right. And we have the probability that T is greater than 3.3605. Equals 0.0060. Well, my p-value is 0.0060. My alpha is 0.05. Make them the same length. This is less than, so our decision is to reject the to reject the null. It's like, hey, you know what? We just said strain 1 definitely has more lesions, all right? Or at least that's what our data shows. The next thing, it says create a 99% confidence interval for the same problem. So our formula, X bar plus or minus T star S divided by the square root of N. Well, what's our mean difference? Well, our mean of our difference was 2.75. The standard deviation, well, I mean, the sample size, very small at 8, so you know we're going to have to graph those differences, but we'll do that in another video. Our sample mean was 2.3145. We got that from up above. All right, we got that from up above. And degrees of freedom are 8 minus 1, so we have small degrees of freedom. So now we know our degrees of freedom. We can calculate T star. It's going to be an inverse T. We know that by now. Area 1 minus 0.99 divided by 2. Degrees of freedom, 8 minus 1 equals 7. So second vars, inverse T, clear, parenthesis, 1 minus 0.99, close parenthesis, divide by 2, degrees of freedom, 7. And we get 3.4994. So T star, that's a pretty big T star, and it's because our sample size is so small. All right? Plugging in 2.75 plus or minus 3.4994 times 2.3145 divided by the square root of 8. I'm drawing. Please remember, we put the sample mean here because we're trying to estimate the population mean. So 2.75. Then we have a lower bound and an upper bound. This area is 0.99. So my area in the tails, parenthesis, 1 minus 0.99. That's my alpha divided by 2. And we get 0.005 in each tail. Really, really small amount, 0.005 and 0.005. That's my area in the tails with an alpha of 0.01. Inference procedure. Well, it's a one sample, T interval for the mean of the differences. And it's really important that you keep this in right order. So mean of the differences, because at some point this is going to change. So for the mean of the differences, all right, then stat, test, t-test, excuse me, we're not running a t-test, we're running a t-interval stat test. T-interval. We can use our data, make a confidence level of 0.99. And there it is. Somewhere between negative 0.1137. So it's possible at the 99% level that fungus 2 will have more lesions, to as many as 5.6137. All right. I hope that helps. It's a good introduction to the paired t test. Look forward to seeing you on the next one. Thank you.